My name is Dotson. I'm a senior technical staff member at IBM and an executive architect. I think any security person will start talking first about threat models, and so you first have to understand what it is you've got, your asset management, and who's out to get you, most importantly, and what kind of techniques and things that they will use. But that said, in a general sense, so that'll inform what types of things you do and what controls you do. There are some things that are fairly uniform, right? And I always tell people, first things to do are first asset management, knowing where you are, because that's important for doing your other controls, and then vulnerability management, and then the third is identity and access management, and making sure that you're tightly controlling who gets in, particularly for privileged users and what kind of access levels they have. So we don't generally like use the castle and moat type of idea. It's still useful in some cases, but for the most part that leads to architectures that we call the soft on the inside and crunchy on the outside type of thing, like a piece of candy. And so from there, we do want to reduce the attack surface as much as possible, and things like network controls can do that. I typically consider those, even though I'm a network guy at heart, I love networking, but I typically consider those things to be either a first line of defense that you expect to get breached, or a last line of defense to try and catch you. So in terms of putting things on cloud, I think that a lot of the stuff is the same as what has been the case in traditional on-prem data centers, but some of the tools and some of the delivery models and stuff do change how you do each of those things quite a bit. As an example, for network controls, it used to be that you would have a blinky box of some sort that was your firewall, and maybe a blinky box that was your IDS or IPS, and maybe a blinky box that was your WAF, and so on. A lot of those things now are not boxes. They're either built into the platform. For example, with container-based architectures, you can constrict the flows of what's allowed from pod A to talk to pod B, or pod B to talk to pod C, or incoming from the perimeter. You can actually build that in with your definition of your application environment. The container-based architectures can inherently be more secure in some ways, because it allows greater microsegmentation. It allows you to have some of your security as code, so to speak, when you deploy it, and things of that nature. So that can really help. On the other hand, from a purely technical standpoint, in one area, having the isolation of a virtual machine environment can be more secure, in the sense that the hypervisor has a smaller attack surface, fewer things that it is providing to the workload that could be exploited, whereas the container, you've got the entire Linux kernel, or whatever kernel you're using, but generally Linux kernel, available to you as an attack surface. So every single syscall that you could possibly make could be a vector for attack. So, and then even, as Spectre Meltdown proved, even virtual machine isolation isn't perfect. Sometimes you need separate bare metal machines because you need to be running on physically separate chips. Things like Rowhammer and Spectre Meltdown and all sorts of things like that, just by virtue of running on the same physical hardware, there's some side channel attacks that you can exploit to get data out of places that you're not supposed to be able to get them. So it's a continuum. On one hand, from an absolute attack surface standpoint, the most secure is using separated hardware, and hardware like IBM Z series that has the hardware partitioning and memory partitioning and memory encryption and things like that. On the other hand, so some of that can be done at the hardware level. On the other hand, you can't neglect the overall architecture, and in some cases, using a container-based system might actually lead to better overall security, because even if you're just slightly weaker in one or two of those other areas, you might be much, much stronger in areas that are, for your threat model, more important. Well, so one example you gave is I've got customers, they download a mobile app. Maybe the mobile app is susceptible to snooping on the mobile device. There's some other evil app that's talking to my financial app and masquerading as me and transferring money around or things like that. So that's absolutely a concern. And to some degree, you're at the mercy of what the platform provides you there. But there's plenty of defensive security things you can do when you're creating those apps. On the other hand, another threat actor there is just somebody who signs up as one of your customers, but is actually malicious. And so in that case, you realize you also can't really trust the user or the app. And at that point, the entry point into your infrastructure becomes very important, and you should constrain that down to as little as possible, and then make it, multiple layers of security within there. Okay, the users, you're going to let the users in to talk to, the old classic 3-tier webs. App, you're going to let them talk to the web server, and then from the web server, you can only make certain calls to the app server. So even if somebody takes complete control over the web server, for everything in your environment, you should be able to point to it and say, what happens if somebody compromises this thing? If somebody breaks in and gets to this particular thing, sometimes the answer is game over, right? I mean, when there are some pieces of your architecture that the best you can do at that point is I will catch them and kill them quickly, right? As opposed to, if you already posited that they got into your back-end data store, then at that point it's, how do I keep them from exfiltrating data without me knowing it? How do I slow down the exfiltration of data, and so on and so forth, and then proper incident response and stuff on top of that. Then you also have to at the infrastructure layer, you have to do the same types of things you would do on-prem, but maybe in a different fashion on your cloud infrastructure where the mobile apps talk to, and keep somebody from DDoSing it and taking you offline and holding you ransom, keep somebody from breaking in through the front doors, keep somebody from breaking in through the back door through your privileged user management. I mean, if you've got a lot of money and your privileged users can get around the controls and transfer that, not surprisingly, they're going to start getting phishing attacks, spear phishing attacks, and all sorts of things. So that leads in, to the human factor of you can't have just technical controls, but you also have to have the right procedural and human controls to try and prevent that, to the level of sometimes of having multiple sign-offs. No, I mean, we're all going to die eventually too, but it doesn't mean we don't take precautions against having it happen too quickly. So no, I think there is a temptation in security to be a little too fatalistic sometimes. Sometimes it's good enough to just be, make them go bother the other guy, right? Sometimes you don't have to outrun the bear, just the other guys.